Hello everyone, good evening. Welcome to week 2 problem solving sessions on the course on essentials of data science with R software, where we are learning about sampling and linear regression. I'm Shreya, one of the TAs for this course, and today I'll be briefly explaining or going over some of the week 1 contents which remained in the last session. I'll be discussing some of the data structures and how to handle them in R, and then after that I'm going to move on to week 2 content and discuss basics of sampling, the introduction part, and then I'll proceed to solve some problems which will help you tackle the assignments hopefully better. So let's get started. So I hope my screen is visible. So in the last class we learned about how to use R as a calculator. We learned a lot about operator precedence. We solved some questions. We also looked at vectors and how to list and subset elements in a vector, how to perform operations on elements of a vector, and how to access elements, take a subset. Also, we learned how sequences and repeat elements work in R. We also navigated through some basic built-in commands that are really useful. We also learned about how to tackle mixing data, what is the sort of keyword that R uses, and how we can navigate through tackling missing data primarily by removing it and considering complete cases or replacing it with some other value. And we also looked at matrix operations and some of the logical operators, and also a little bit about subsetting. So today I'm going to start from data frames. Okay, so data frame is a data structure which is different from matrices in the sense that all elements in a matrix or in a vector have to be of the same data type. So if I have a matrix of numbers, then every element of this matrix should be a number. If I have a vector, let's say, then every element of this vector should be of the same data type. But this is not true for data frames. So data frames is actually an equivalent of a table, you can say, where one particular column will have one particular data type. So how do we actually create a data frame in R? So let's do that, creating a data frame in R. So first things first we can do is we can first decide on the columns. So let's say I want to create a data frame which needs to have a column, and the column name should be name, and I am also storing another column which I call as marks, where I am storing the marks obtained by each of these candidates. Okay, now in order to there is some, yeah, so be careful when you copy from elsewhere, because if these codes change, R might not work. Alright, so we have this character array of length 5, which stores the names. We also have the marks array, which stores the name marks corresponding to obtained by each of these 5 candidates, let's say. Now if I want to create a data frame, all I need to do is I have to give my data frame a name. So I am giving the name as my data equal to data dot frame and then name comma marks. Okay, so once I do that, you can see here I'll have a my data which is a data frame, and I will have so I have this data frame which has like 5 observations on 2 variables. Okay, so I have been discussing how we can actually create a data frame in R, and this is how we do it. This is one of the ways how to do it. First we specify the columns that we want, and then just use this data.frame command, and in a comma separated manner we just write out the columns that we want in our data frame. Alright, now if we want to, this is one way of creating it itself in R. Now let's say most often than not what happens is that you are already provided with some sort of a table, and you need to it's not always feasible to replicate that table in R, type it out and then use it as a data frame. That could lead to errors because of this manual work. So it's always advisable to import data set from known formats. So it could be from a CSV file, it could be from a TXT file, it could also be from an XLSX file. Okay, so to do this you might need a different package, but I'm going to show how you can import from a .txt or a .csv file. So .csv usually is the delimiter is comma, okay, and .txt usually the delimiter is a tab, could be a space as well. Okay, so what you need to do is that, so let's say here I have one data frame, okay, where I have name, age, gender and height information of 4 individuals, let's say, and I have this stored as week2.txt in one of my folders. Okay, so what I'm going to do is that I'm going to navigate to this folder and I am going to get the path of this file. So the command will be, so let's say this data corresponds to height, so height data will be the name of the data frame I am importing my data set into. So I'm going to write read dot table, then within quotes I'm going to specify the path, and then the name of my data, the text file that I've stored, and I want the headers, so I am going to explicitly specify header equal to true. So once I run this, oh, they're saying they don't have this file. So this is stored somewhere else. Okay, so it's not stored in Mac2, it's stored here. So I have to give the correct path. Okay. Uh, Let me just find out what went wrong. So height.table, and then we are providing the path and header equal to true. Let's find out. Hmm. Okay. I set my working directory as this one, and then if I put saving this as week2.txt, and then I'm writing week2.txt. Why is this coming? There must be some problem with this. Okay, here it is. So they are throwing some warnings, but it got loaded. Okay, so here is the data frame: name, age, gender, and the height in centimeter. Alright, so here, as you can see, I have 4 columns, and 4 of the columns have different data types. Now if I want to look at what is the structure of my data frame, in RStudio what I can do is I can click on here and see that name is of type character, age is integer, this is also a character, and height is an integer variable. If I don't have this R interface, I could also use the command str to look at my height data, and it's going to give the same information in the console over here. All right, any doubts so far? Okay, so this is how we load a data frame into R. Now let's say I want to look at, let's say, the age column itself. So in order to subset, by column, I can write like age equal to height data $sign, and then once I press the dollar, this prompt is going to come, so I can select or type out whichever column is it that I want to access. So if I give height.age, then this age variable is going to store the age column reported in this data frame. Okay, so here I have an age column which stores the age data frame. Now let's say I want the age and height in a separate data frame. So I can write age height, this is the name of the new data frame, height data within third bracket. First I'm going to give comma. Comma represents all rows, and then I'm going to specify the columns. So I am going to write C age concat age and height, but I have to be careful. The name of the column is height_cm, so I'm going to write this and then press run it. So you see age height will only have the age and the heights. Okay, so this is how you select columns. You can select a single column, or you can also select more than one columns in this manner. Alright, so once this is done, next if I want to subset only the heights of female individuals. So if that is the case, I want to select height of female candidates. So what I'm going to do is that I'm going to find out from, I want to select it from the height data original column as well. So which height data dot $gender equal to f. So height data equal to f is going to give me, is going to return true wherever the index, it is going to return true wherever this condition holds true. So since the first two elements in height data is female, so when I'm doing this, which height dot dollar gender equal to female, it's just throwing me true true, false false. Okay, now I have these. So if I do which over these, then it's going to give me the indices where the row indices where this condition holds true. Now once I have the rows, I am going to write the height dollar data such that these will be my row indices, and then comma, what is the thing that I want? I want the heights. So I'm going to specify the column that I want. So that would be height cm, and I'll close the bracket. So this is what I get now, 61 and 164. Now if let's say I want all the rows, all the columns corresponding to females, then I am not going to write anything. I'll just put a comma, and then I'm going to get all the other variables associated with this female. Okay, just a comma will give me all the other columns. And if I want not all but a few, I'm going to write this thing, and here within this C I'm going to mention whatever I need. So I might want the name and the height. Alright, so this is how I'm going to select columns or rows of this data set. Okay, simply if I want the second row of this data, let's say I want the second row, then I am going to type height data 2 and comma. So it is going to give me the second row. Okay, so all of these complex things are actually this one, the first part is actually returning the indices, the row indices, and then when we process that, then we are getting that information in that is present in that particular row. Is it clear? Is there any doubt? Please let me know. Alright, so this was about subsetting data frames. Now let's say I already have this data frame, this one, my data. Okay, and I want to add another, sorry, আমি ক্লাস নিচে পড়ে কথা বলছি। Yes, so sorry about that. Yes, what I was saying, so I have this data set, my data, which has marks and names of 5 candidates. I want another variable which will tell me the classes they are enrolled in. Okay, so I can just write down my data dollar name of the new column that I want. Let me want it as class, and I'm going to give this thing. Okay, so now when I run my data, I am going to see what is happening. Yes, so now I have 3 columns: name, marks, and class. Okay, now if I run this command, this will also subset my data. This is going to subset in such a way that it's going to select class, students enrolled in class 7, and it's going to give me all columns but the second one. Okay, so let's see here. So how does this work? So first thing I have to specify is my data frame. Second thing is the rows that I want. Class equal to 7 is going to return true or false according to the rows. And then the next thing is the columns that I want. So if I had given +2, then it would have returned only the marks. Okay, but here if I give -2, it will only return everything except the column that I'm specifying here. So to put it very simply, if I want to subset, let's say I don't want specifically second and fourth row. So there are 2 ways to do that. One is, first I just write down 1 and 3, since I know there are only 4 rows, and a comma. But let's say I don't know how many rows this data set has, but I am sure I don't want the second and fourth row. So what I'm going to do is I'm going to write my data minus whatever I don't want, that is 2 and 4, and then I want all the columns, so comma over here. Okay, now you see I only get 1, 3 and 5. Alright, similarly, if I just want all the rows but not the second column, so all rows but not second column, I'm going to give my data comma for all rows, not the second column, so -2. Is it okay? Do you have any doubts? Please let me know. Okay. Another thing that I want to discuss is that this length of my data is going to give you, length of a data frame is actually going to give you number of columns it has. On the contrary, if you give length of a vector like the value over here, let's say age, this is going to give you the number of elements present in the vector. But for a data frame, it gives the length command gives the number of columns for a data frame. But the same command gives number of elements for a vector. So if I really want to know that how many rows does my data frame have, I have to use the command nrow. Okay, nrow my data is going to give me the number of rows that I have, that is 5. Okay, nrow of the other data frame that I'm using, height data, is going to give me 4. Okay, so this was a little about data frames. We learned how to create one in R. This is the command that we should be focusing on, data.frame, then the actual vectors that make up the columns. How to import it, so we can use data.table if it's a txt file. Similarly, we can also, so by default data.table will be tab separated, but if we have some other separator stored in that file, we have to just provide sep equal to and the separator here. So in my file it's a tab, for you it could be a semicolon, it could be a hyphen or anything. So you just have to specify your separator over here. Alright, another way to do is you could also use this read.csv and the same thing. But we have to be mindful in this case, because CSV automatically assumes that the separator is a comma separator. So if you are using CSV, then you have to explicitly specify that no, the separator in my file is actually a tab. This will also work. Okay, you have this. Fine. So next we learnt about how to subset single columns, more than one columns, and then select subset rows and columns simultaneously, and then a little bit about how to determine whether the number of columns and number of rows present in my data frame. Okay, I'll next move on to another type of data structure, which is called a list. Okay, similar to data. So before that, is there anything that you want to ask? You can let me know if you have any comments, any doubts or anything. Alright, so next I am going to move on to lists data frame. Sorry, list data structure. So here again, this is how you prepare a list. Okay, I'll break it down one by one. So let's say the difference between a data frame and a list is that data frame versus list is that in a data frame, all the columns that you have should be of the same length. It can differ by type, but it has to be of the same length. So if what I mean to say is that if I have something like this, then I can store it in a data frame. But let's say I have different data types and different lengths. For example, if I have 5 names here, A, B, C, D, E, and I have 2 ages, let's say, this column also has some female, 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 male, 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 something like this. So if we have uneven rows, then the best way to store this information would be in the form of a list, provided we don't want, like everything will depend on the objectives that you are trying to achieve. If the data is such that this all the rows correspond to a single individual or single entity, then probably a data frame is a good option. But there are cases where you don't need to store it as a data frame. Okay, it will vary from case to case, but when you have varying lengths, then data frame won't be able to handle this thing. So that in that point of time we have to use a list. So here again, what this is doing, this part is creating a vector called numbers, and there are 2 elements. This part is also creating a vector, but it is a vector of characters of 2 elements, and this part is again creating a set of numbers, but there are 3 elements. Okay, so this and this is done. Now what they are doing, now they are just like we did for data frames, data.frame, and then we specified the columns. Here at one go we are just specifying the columns. So let's say numbers, letters, and here again I have something called numbers. So this is my list. So I have a list of 3. So I am storing 3 types of data. This is how the indices are represented in case of a list. So the first list is of type double. The second list is of type character, and the third one, is also of type double. Now if I just want to subset the third list, how do I do that? I'm going to write my list, and then you see here how it is represented. It's represented within double third braces. So that's exactly how we are going to call it. So I'm going to write double brace 3. So this is going to give me the third list. Okay, so if I want to create a list of data frames that are already present, so let me just give it name as list df equal to list, and I have created 2 data frames so far. So one will be height data and the other will be my data. Okay, so then this list df is a list of 2, where the first list is this data frame which contains information on height, and the second list is this data frame which contains information on marks. Okay, now if I want to go further and select these things, let's say in my list I want the second, I want the third, I want the second element of the third list. So I want to query 4. All right. So if I want to query second element of third list in my list, how am I going to do that? So my list 3 is actually returning the entire list and I want the second element, so I'm going to write 2. So this is giving me 4. All right. If I want the first and third, second element, first and second element of third list, I am going to write the same thing. Within the next one I'm going to write 1, 2. So this is going to give me the first and second element of the third list. Similarly, if I want to query this height column from my list df, so let's say I want to query height column from list df. So this is how the list df looks like. First I have to select this height data frame, so we'll go sequentially. So this would give me, so list df $$1 is going to give me the height data frame. Now I want to query the height column, so I'm going to write dollar and height centimeter. So this is giving me the required column that I want. And now if I want to query the height column from list df and view the height of person D, let's say. So what am I going to write? So this would be list df $1 height cm. This is going to give me the height column. Whose height do I want? Which list $1 list $1 name equal to D. So this is now giving me the height of the person D, that is 167. Okay, so when we have this sort of complex things, we have to go sequentially. First we have to go inside the list that is holding this sort of a data. Then once we have the data frame, we can query with respect to the column that we want, or we can just use the subsetting techniques to get to whatever the value that we want. Okay, is there any doubt so far? Please let me know. All right, so this was about the how to query from a list. Now the next thing is structure and dimensions. So as I said, this command is really useful. If I just write structure list df, it's going to give me the entire data structure. It's a list of 2. It's a list of data frames, and what are the columns in that data frame, what is the data type. And if I just mention dim list.df, I don't get this. But if I just mention dim of height data, then it's going to give me. So dim will work only for data frames. Will it work for arrays? Let us check out. So dim letters, no, it's not working. So dim is going to give us the dimensions of our data frames. Okay, and str is going to give structure of any data. Okay, like this gives that's the data frame. If I input a list, it will give me that it's a list, and so on and so forth. Okay, so now that we have this, we can easily use these inbuilt functions to look at the mean, standard deviation, variance. So if I want mean age, then I'm going to write height data $age mean of that. Okay, so it's actually 56.75. If I want the variance, if I want the standard error, standard deviation, then also this thing. Okay, so in order to do that, we just have to query the column and then use these predefined functions. Alright, now let us learn a little about plots. So let's say I want to plot this the names and the ages, let's say. Okay, so if I just plot x equal to height data $name and y equal to height data $age, okay, and type equal to, I'm giving age, let's say. Sorry, if I just give bar plot, let me just find out what are the, okay, so creates a bar plot with vertical or horizontal line. So I want a bar plot of the age, let's say. This is what it looks like. Okay, this corresponds to A, this corresponds to B, this corresponds to C, this corresponds to D. Okay, if I just want names dot arg equal to, I have to specify height data $name. Okay, if I want to add a title to this club, to this plot, I am going to write main and let me write bar plot. Okay, if I want to add x labels, So I'm going to write x lab and then name, and y lab is my age. Okay, so this is how you draw a bar plot. All right, now let's say I want to have a scatter plot, okay, of age and okay, before going on to scatter plot, let me assume I want a line plot of name versus, like on x-axis I will have the name, and on y-axis I'll have age, and then it will be joined by a line. So in order to do that, I am going to write plot height data dollar name, and height data, this would be y equal to, this is x equal to, you can skip these, but just because we are doing this initially, dollar age, and then type equal to L. Let's see. Oh, no. So x also has to be numeric in this case. So when it is categorical, the bar plot is the only thing that we want. So let's say we want a line plot where x is actually age and y is a let's say height. Okay, so then I'm going to write x equal to age and y equal to height, centimeter, and then type equal to L. Okay, so this is how it is looking like. If I give main line plot, okay, x lab, let's say age, y lab equal to height, then this is how it is going to look like. Now if I just give type equal to B, we are going to have these circles at the edge points and in between joined by lines. Okay, now this same thing, if we want like a column plot, then if we change this type to H, we are going to get this sort of a column plot. Okay, and if we don't specify any sort of type, so if we don't give this type command here, then whatever we get is actually the scatter plot. Okay, and this is actually my scatter plot. Alright, so this plot command, bar plot command, is little helpful in doing these sort of things. Okay, alright, now let us see what scatter dot smooth does. So if I just give scatter dot smooth, Alright, we'll have to just find out what it does. Okay, scatter plot with smooth curve fitted by Lewis. So it will add a certain curve to my scatter plot. So if I have lots and lots of data, so let's say I'm going to generate some, let's say x1 equal to r unif 9 or 90. So I'm generating 100, or let's say 100 from uniform 0 1. Okay, and y1 is also generated 100 from uniform 0 1. And if I just write plot x1 y1, it's going to give me a scatter plot. So if I just write scatter dot smooth x1 comma y1, it's going to give me this. And then if I specify color equal to red, then oh, okay, and it's going to give me all the colors in red and the smooth line in black. I could just look up all the other things, x lab, y lab, those sort of parameters, and then just plug in. Alright, so this was about a little bit about plots. Okay, so this was about plots, and the last part that we are going to cover is actually correlation plot. So to do that, we need a library called corrplot. So let us just install library corrplot. Okay, and let's say I want correlation plot between age and height. Okay, so this is something I want. So I'm going to give corr plot equal to, okay, so I'm going to give correlation x equal to this and y equal to this. Sorry, it's going to come this thing. Alright, and if I just type this thing, so let me store this as correlation, and if I just type this thing, Okay. So if I do have a correlation matrix, then that will happen if I have more than two variables. So yes, so let me just uh, find out. If I just add something, height, dollar height data, dollar weight equal to, let's say I add 88, 65, 78, 82. Okay, and then I have correlation height data between age, height, and weight. Okay, so then this is my correlation matrix, and if I do a core plot, then I'm going to get these numbers. Okay, if I give these core plot dot shade, then it's not going to report the numbers, but the intensity of the color is going to show me whether I have weak correlation or a stronger correlation, and this is going to create ellipses. All right, so yeah, that was about it. Even if we have two variables, this is going to work. All right, initially the problem that I was having was I was not specifying the correct column name. So now that I have specified the correct column name, it's coming. Also, if I just add one more column, it's going to give me a 3x3 correlation matrix. So the core command here is actually giving me the correlation matrix, and core plot of this matrix is going to give these sort of results. All right, okay, so that was about some of the week 1 concepts. Now I'm going to, you can use these examples to try out. This is already available in the Google folder, and now I'm going to move on to week 2 lectures. Okay, so in week 2 we learnt about sample versus population, and what or why is sampling necessary, and what are the use cases. Not in great details, but we just touched upon these sort of concepts. So first I am going to introduce these terms once again, and then we are going to move on to do some of the problems. Alright. So the first thing is, whenever we are talking in terms of samples, this is usually with respect to a population. So population, let's say I have, just a minute. Okay, so let's say I have defined my population as let's say all individuals or let's say all Indian individuals with age greater than equal to 70, let's say. Okay, so this, if I specify this to be my population, then all the individuals who are residing in India and with an age of greater than 70, that is my population of interest. So this term population will actually vary with the research question or research context. Okay, so how does this population how is that defined? So this is actually, let's say, defined in terms of some units. Okay, so let's say unit 1, unit 2, to a large number, let's say unit 17 lakh something something something. This actually is my population. Okay, now from here, if I select a handful, let's say I select 10 or 20. Okay, so that would be, let's say I select U3, U4, U100 or U201, something like that. So then this is actually whatever I'm selecting from the population, this is actually my sample. Okay, so sample is actually a subset. So sample is actually a subset of my population. Okay, and why is it necessary? Because most often than not, the primary goal is that here we have a population P. Okay, from here we take a small sample S, we apply all sorts of statistical tools and we get estimates about the, we get some sort of estimate which gives us some notion about the population P. Okay, so we are selecting few units from the population and then applying all our techniques to this unit to make meaningful inference about the population. Okay, so this is actually the primary goal of statistical inference. All right, now just by the design of what should be a good method of inference, it's commonplace to, I mean, it is not hard to see that how good my inference would be about the population will actually depend on how well I am sampling from this population. Okay, so sample quality is of utmost importance so that whatever decision whatever decision rule I formulate with respect to the sample at hand, that is easily and accurately generalizable to the population. That is my entire goal. All right, so here we need to learn what are the techniques and how we can draw good samples that would be representative of this population. We want this representation to be as precise as possible so that whatever inference we draw based on the sample can be easily extended to the population. Okay, in the lecture notes you must have heard a lot of examples like the one that Sir provides about the medicines and clinical trials. So let's say one drug is manufactured in the US and then it's tested out on individuals in that country, but then once it successfully passes clinical trials, that medicine is made available for the whole world. Okay, so in order to do something like that, we have to ensure that the number of people where this drug is tested, that is a good representation of the people habitating the entire world. Okay, so this is the primary concept. So population is my bigger set of units, and from that we are just selecting a few, and this selection could be guided by some probabilistic measure. This selection could be based on some sort of judgment that the researcher might have in mind. There are different techniques of selecting a sample, we'll get into that. But the end point is that we need the sample to be a good sample. This has to be good so that whatever inference we make on the basis of this will be generalizable to the population. Okay, I hope I am clear. So now I am coming to sample units. So let's say if I have U1, U2, UN, this is actually my population. Then small u1 star, small u2 star, small un star, this is actually my sample, and these are actually the sampling units. So let's say I am carrying out a market research survey. Okay, and my target population is youth. Okay, let's say between age 18 to 25. This is my target population. So all individuals within these age group is actually forming the population. And sampling unit is what then? The sampling unit would be an individual of age 18 to 25. So then this actually is, so I am collecting data on these individuals. So these individuals are actually my sampled units. Okay, another example is, let's say I have a drug in the market, drug A, and I am testing it out and conducting clinical trials. Okay, and then I am just doing a before after sort of an analysis. So in this case, again, my sampling unit would be an individual or a patient who is participating in the trial, because I am collecting information on those participants who are participating. So that is actually my sampling unit, or in other words, you can say units as well. So if I take the all possible sampling units, then that set is actually my population. All right. Okay. Then we learned about why, or what is the difference between a sample survey versus a census. Okay, so census is like a complete enumeration where data is collected on all possible sampling, on all the sampling units. Okay, or in other sense, the population, like that 10-year census that we have in India, where each and every individual is documented and their data with respect to age, name, and everything is stored. Okay, so this is census, where we take information from the entire population. But sample survey is different. We just sample a part of the population and collect data on that part. Okay, now while this census is more accurate, because we don't need to make any guess. So if I want to know what is the average height of any individual in the country, I could just look at the height register, if there is any, from the census data, and just take an average. That's okay. I could do that. But the challenge is that collecting census data is not as easy as it sounds. Okay, so with respect to demographic surveys, I can say these are not uh, that easy to carry out. There are a lot of factors that are involved. Okay, there's cost, there's time, there's resource, there's manpower, and it's not easy to especially in a country like ours where there are billions of individuals residing, going to every single individual and documenting their details is a humongous task, and it's not always uh, cost friendly. But if we, on the other hand, we have some notion about how our population looks like, then if we can select a handful of individuals who represent India as a whole with respect to its intrinsic features, like let's say we collect samples from both the genders or all the genders, across all age groups, across all socioeconomic backgrounds, across all educational qualifications, then uh, or across some other parameter, like in rural areas, in urban areas, and uh, having I mean we could collect in data on healthy individuals and a little bit who are diseased. So that would if we have a sample where we have all sorts of individuals who satisfy these sort of criteria, and then if we just calculate the mean of that sample that we have collected, then oftentimes we see that we get a good estimate of how the population parameter, in this case population height, would look like. Okay, so this is way less cost, way more cost friendly, and it can give us accurate results without having to go through the hassle of carrying out a census. Another particular application where it's not possible to carry out a complete enumeration is when we are talking in terms of quality control. So let's say I am manufacturing a bulb and I want that bulb, I want to test that remains functional for at least 5 years. Okay, now if I let's say I produce a lot of 500, and then I want to check how good have I produced, how good the lot is. Now if I just keep on switching on, if I keep on burning the bulbs or lighting them up until they get fused, then if I see that okay, all of them, you know, survive for 5 hours, 5 years, then ultimately at the end of my experiment I will have no bulb to sell. So that is an example of a destructive experiment. So then I have to strike a balance that I can only test, say, let's say if I have produced 500, I can only test 100. Other 490 I have to sell because that's the end goal. I am selling bulbs and I want a little bit of profit for myself while ensuring or not compromising on the quality of the bulbs. So in those scenarios it's not possible to carry out a complete enumeration, that is, it's not possible to take data on every unit in the population. In those cases especially, sample survey is the only way out. All right, so that was a little bit about sample survey versus census, and it's a no-brainer that our samples that we are drawing from the population has to be representative. So one of the the most used way would be, if I have this population P, this will have some intrinsic features. So my sample that I have should have those features. Okay. So this is a very important concept, and it's not difficult, but it's not very straightforward oftentimes. So we might have to think, because there are trade-offs involved. If I want a representative sample from of India, and I go to great lengths to get these samples, even then practically there would be constraints. So at that point of time, we have to make a trade-off between the cost and representation. Okay, now having said that, if I have two samples, let's say S1 and S2, where S2 provides better representation and S1 is, let's say, missing out on some, okay, and we are aware of that. If so the question then becomes, which one do we do? Should we go ahead with S1 or should we go ahead with S2? In any case, it's always go ahead with a better representative sample, but that doesn't imply that the samples that are collected which miss a few of the features, they are not samples. They are also samples, but the thing is that whatever inference we draw from these sort of samples, we might have to take it with a pinch of salt, or I should say that we should exercise caution while generalizing to the population. Okay. So how do we ensure representativeness? So there are a few techniques. The first one is by random sampling, okay, where if we randomly sample from a population, it is expected. So this would be guided by probabilistic principles. Okay, it could be equally likely or it could be not equally likely. Okay, but there would be some probability principles which would guide how to select. Non-random sampling is that it would be very judgment oriented of the researcher or the one who's collecting the sample. Okay, so if I decide that I am going to consider samples from, let's say, a particular sector of the society, and that is based on my judgment, so those kind of decision making, if that goes into picture, then that sort of sampling would qualify as a non-random sampling. Okay, and quota sampling is that sampling technique which is actually uh, applicable for rare diseases, where we keep on sampling till, let's say, Q number of cases or that Q quota is encountered. Okay, so if I am sampling, let's say, if I am interested in a very rare disease which is not usually found in India, then it's expected that if I take 10 samples, maybe I'll get one individual who's having that disease. But I need actually have to develop some idea about the disease. I need at least 100 people who have that disease. So then I have to fill up this 100 quota. So I have to sample till I get 100 patients with that disease. So those sort of sampling is actually called a quota sampling. Okay, and it's usually used when we are looking for some rare event. All right. Okay, so that was about ensuring representativeness, and then we also talked about sampling frame. So sampling frame is that all the sampling, the units or population, every sampling frame has an ID associated with it. Okay, so if you remember the example with the colorful balls, okay, that was provided in the lecture. So if I can list all the people in a population, that would be my sampling frame. So if I U1, UN, let's say, are IDs associated with the population, then this list is actually my sampling frame, because I am sampling from here. Okay, so it is actually a resource, or it is actually the sampling source, I would say. Okay, and this source is associated with a with an ID, some sort of an ID. So what I mean to say is that if we enlist each of the units, and each of the unit has its own designated identification number or identification code, then that entire list is actually my sampling frame. Okay, so it's actually a list of all the items or all individuals that could be sampled from the population. Next, coming to advantages of sampling over census. So cost and scope, I said, it's for sampling, cost is less and scope is also better, and organization of work is easier because there's less resource involved in case of a sampling than in case of census. And when you have too many resources and too much of work, then accuracy will tend to decrease. All right, and census is very, very time consuming, especially in a large country like ours. And if we need some information urgently, then sampling is the way to go about it. And there could be, as I said, like, especially in case of quality control, you would manufacture experiments. If you want to test them out, that would be destructive to you. Okay, and so in those cases, sampling is the only answer. And in some cases, there would be ethical concerns, Like if you are, testing out a drug or something, and people, like, people have a right to say no to whether they want to become a part of that clinical trial or not. So you cannot just say that, no, I have used this drug, so I'm going to apply it to everyone and then see what are the repercussions. No, this is not going to happen. So for those concerns as well, sampling is the only way to go about. Okay. And also we discussed types of surveys. It could be economic, it could be demographic, educational, employment, or all these things that was discussed in the class. And we also briefly touched upon the steps in conducting a survey, like how should we decide to go about performing a sample survey. So the first and foremost thing is we should decide what is it that we want to study, what is the objective that we are trying to achieve with this sort of a survey. Then the next thing is that will also be based on my study question. What should be my population, and what should be the sample units, and then what is the sort of data that I want to collect on these uh, individuals or something. So let's say if the objective of my study is to find out percentage of obese people in India. Okay, this is something that I want to find out. So my population would be individuals in India. Okay, sampling units would be individuals. Then data would be, what data do I need to see whether I have obesity or not. Maybe I need BMI data, I need waist to hip ratio, or some other weight, height. These are the things that I need. And then the degree of precision of the data. So I want BMI up to, let's say, 2 decimal places. Okay, I want to calculate height in centimeters. I want to calculate correct up to 2 decimal places. I want weight correct up to 2 decimal places, something like this. So the data that I want to collect is information of on these variables, the variables collected from these individuals. The next would be the method of measurement. So how am I going to get the height, weight, and BMI and this thing? So I could just use measures. Okay, to get the I could do a standing height, sitting height, and do some sort of calculation or something like that. Okay, if let's say I want to look at hypertension or something like that, then I need systolic blood pressure, I need diastolic blood pressure, the low ones and the, I mean, we have two types of blood pressures, so I need those calculated. Now especially for this hypertension thing, I could collect from right hand, I could collect the measures from left hand, from right leg, left leg, take an average, or do something else. So I have to decide on how I'm going to take measures that will help me uh, answer the question that I want to address. Okay, and then once I have the sampling unit decided, the sampling frame is also decided, because that will be all the individuals in the India, all individuals living in India, I'm sorry. And then the scheme of sampling, do I want to sample randomly, do I specifically want to target a particular section, do I, I'm just going to use my judgment and convenience to get the samples. That's up to me. That is one thing I should decide. Now the next thing is I should carry out a pre-test. So the thing is, whenever we go for surveys, it could be a large scale survey, it could be a small scale survey, anything. it's important to validate a few things before we go in for a survey. Like if I have designed a questionnaire, in my mind it reads perfectly, I can understand what I want to ask and I can answer. But you give the same questionnaire to another person who is not exposed to your environment perhaps, so they might interpret questions differently. You might want a particular type of answer, but they might interpret questions differently and they might not be able to understand the questions correctly so that they can answer you properly. Okay, so these are some of the nuances that we need to take care, and it's best that we do a mock survey so that we know that whatever questions that we've decided, whatever metrics that we have decided, those are valid. Sometimes what happens is that it could happen at any stage that you decide on a certain measure of the method of measurement, and then you find practical constraint associated with that. Now, until and unless you go to that field, that practical problem might not be visible to you even. But if you carry out a small scale mock survey, which would mimic the procedures that would happen on field, then you would be better prepared to design the survey in such a manner that the final objective of your study is achieved with greater accuracy and less hassle. Okay, now once all of this is done, then we have to organize or delegate task, because field work is not a one person's job. It cannot be done like that. So there would be dedicated teams who would look at dedicated portions of the work. Some would directly go and interview candidates. Some it'll depend, it'll vary from context to context, but you get the drill, right? So it's important that a particular section of uh, personnel is assigned a particular task, and they would be responsible for managing the whole part. And then it requires collating at several levels to get to a clean data set, which then analysts can work on. Okay, so organization of field work, and then data collection. Whenever you are doing a survey, it will be laden with errors. Okay, there would be entry level errors, there would be error in understanding, uh, because just by virtue of this scale of a survey would determine how erroneous your data collection can be. So even if you have everything collected and organized, there would still need to do some sort of data cleaning so that uh, the quality of the data that you've collected is good and it satisfies you. So that is the thing, and then you just need to summarize and analyze, and then if possible you have to store and use this data for future use. All right, so this is also something that we need to take care of. And ideally, the inference that we draw from this sample that we've collected should have minimum variability. So there are a couple of ways that one can ensure uh, that one can undertake to ensure variability control. Before unit selection, we have to decide on the scheme of sampling. It could be cluster, it could be stratified, it could be two stage, it could be double. At the time of sample selection, we have to see whether how we are collecting, is it with respect to some probabilistic measures or some sort of systematic sampling, what is the technique that we are doing. And then once we have the sample, we have to decide on the estimation method that will give us an accurate picture of what could happen at the population level. Okay, And then these are some of the data collection methods. Okay, this could be observations, interviews, mail based, online web portals, web based, registration, transcripts from records and forms, etc. Okay, and one more thing that I want to discuss is I'll be solving a few problems, model questions, and before that I am going to touch up briefly on primary versus secondary data. So primary data is you collect yourself, and it's actually a first hand data. Okay, and secondary data is that data is already collected and stored, you are just using that for analysis. So this is secondary data. So each data has its own advantages and disadvantages, a couple of which we are going to discuss in the next session. So here are 25 questions that I would like to answer. So here we go. So which of the following is the primary advantage of using a sample survey instead of a census? Option A is a census provides a faster and more accurate result. A sample survey is typically more cost effective and time efficient. A sample survey collects data from every member of the population. A census eliminates sampling error by surveying a smaller group. So primary advantage is this, that it's typically more cost effective and time efficient. Definitely a census provides accurate results, but is it faster? No. Sample survey collects data from every member of the population? No. Okay, and census doesn't eliminate sampling error by surveying a smaller group. It may reduce, but it never eliminates. Okay, and it'll yes, it doesn't do that. Okay, next thing is, what is the primary goal of a sample survey? Collect data from every member? No. Conduct a full census? No. Eliminate sampling error? No. There will be sampling error. So the correct answer is to estimate characteristics of a population based on a subset. Alright, moving on. Which type of error is introduced when a sample does not accurately represent the population? So that is when sampling error is introduced. Okay, by virtue of sampling we are getting this sort of an error. Alright, the next thing, in a survey stratified sampling is used to, the option is B, divide the population into subgroups and select randomly from each group. So we have a entire population P which could comprise of, let's say, Q subpopulations. So if we just divide this population, stratify it into Q parts and then select randomly from each of these parts, it could be following some probabilistic measures or something. Mostly it's selected randomly from each of these groups. Then we say that this is actually a stratified sampling. Okay, it's not based on convenience. It is not only survey every other individual, and it does not select participants from a single group. Rather, it divides into different subgroups and then selects randomly from each group. For example, if we want a representative sample of India by stratified sampling, one way is to stratify by states. Okay, and then from each of the states you collect a number of samples randomly. That would be an example of a stratified sample. Okay, number 5. Which of the following is a key feature of a cluster sampling? Selecting every individuals from the population? No. If individuals randomly from different strata? No. This is stratified. Targets only specific individuals, easier to access? No. Cluster is this one. It divides the population into groups and then one of the groups is selected at random. Okay, moving on. Why would a company use a sample to conduct a market research survey? Because it reduces costs and time spent on data collection. Okay, so this is the most appropriate. So the others are not true. They don't serve every customer, then that wouldn't be a sample survey. Eliminating sampling error will only happen when we do a census, so this is not happening. 100% accuracy you cannot expect from a sample survey. Right, question number 7. Which of the following is an example of a situation where stratified sampling would be preferred? A researcher wants to study the effects of a new drug on the general population. Company wants to gather feedback from different age groups about a new product. Factory wants to inspect random sets of products for defects. A politician wants to survey public opinion on a new law across different religions. Okay, so this one is the most effective thing. Okay, feedback from different age groups about a new product. Okay, this one could also seem like stratified sampling, but this is the more accurate and explicitly specified one because it's sampling from different age groups. But here what the politician is doing is he is collecting across different regions, so the politician is not dividing into regions and then sampling randomly, but here they are specifying age groups and they are sampling from different age groups. So option B is the more accurate one. All right. Okay, question number 8. Which of the following best describes primary data? So this is data collected directly from source. This is the keyword, directly from source, through surveys, experiments or observations. All of these existing ones, these are actually secondary data. Which of the following is an example of a secondary data? Survey conducted to gather information on customer satisfaction? No. Data from government health report on obesity rates? Yes, because this data is already collected and available. An experiment is a first-hand experience, so no. Behavior, a researcher observing behavior of animals, this is also first-hand experience, so no. Option B is the correct answer. Okay. Next, which of the following is a major advantage of using secondary data? So major advantages, it's generally faster and cheaper to collect than primary data. Okay, it doesn't allow you more control over data collection process because that's already done and you have no say in that. You're always more accurate than primary data. Well, you don't know what sort of assumptions went into these things while collecting the data, so you never know, so it might not be accurate. Always allowed for more specific tailored insights, this is definitely a no, because if your target population is youth and you have information all across age groups, then that is not tailored to your specific needs, so no. But the one truth is that it's generally faster and cheaper to collect than primary data, and cheaper in terms of both cost and time. Alright, why might a researcher prefer to use primary data over secondary data? Because it is collected for a specific purpose, ensuring it is more relevant and reliable. Because you are in control of your data, any individual would find that to be more reliable. Something which one does on one's own, one would like to believe more on that. Okay. Not easier to find and analyze, not cheaper, not always unbiased. Okay, but this is true, you definitely have more control. Alright, question number 12. If a researcher is conducting a study on public transportation usage in the city, which of the following would be a sampling unit? So public transportation usage, who is using it? The bus rider is using it. So if I want data on usage, the sampling unit would be the bus rider who is actually using that public transport. Okay, not a bus stop. We are not getting any information on usage from any bus stop. We are not getting any information on usage if we have info on the bus route. Maybe it will supplement, but directly it has that variable is not going to give us any estimate on the public transportation usage. But if we ask the bus rider, how many times in a week do you travel in a bus, or how many times a week do you use public transportation, then we can get some data on the actual usage in the city. Okay, so the sampling unit is that person from whom we are collecting the data. So in this case, it would be the individual bus rider. Alright. Okay. In a study of air quality in urban areas, which of the following would be considered the sampling unit? So entire city's air quality levels, air pollution measurements from specific monitoring stations, government's environmental department, number of vehicles in the city. The correct answer would be this thing. I want to study air quality in urban areas, not the entire city. So I would want my measurements coming from specific monitoring stations stationed in the urban area. Okay, so then B will be the correct answer. Question number 14. In a study on the relationship between air pollution and asthma in urban areas, what would be the sampling unit? So the sampling unit would be person who is exposed to air pollution and also asthma. So it would be an individual from whom you are collecting the data, an individual person with asthma. Okay, that would be my sampling unit. Moving on, in a study on the effectiveness of a new drug, what would be the sampling unit? As I said, the individual participants in the trial from whom I am collecting the data, that is my sampling unit. Okay. Moving on, which sampling method is most likely to lead to a representative sample in a study about the general health of adults in a country? So I want general health of adults in a country. So the most representative sampling would be a random sampling from a national registry that includes all adults. Convenience sampling will not give me a general idea of adults in the country, and quota sampling will also not work because we cannot just limit ourselves to predefined subgroups for a representative sample, and judgment sampling is also not representative of the general health of adults in the country. So random sampling from a national registry is the most likely representative sample. Okay, In a survey on public opinion about a proposed law, which of the following would help achieve representativeness? So, this proposed law is going to affect all sections of the society, let's say. So, then surveying from a random person of various age groups and socioeconomic backgrounds would help. Because whenever a law is proposed, it doesn't only affect political experts, it doesn't only affect individuals who express their opinion, or nor does it only affect to urban areas. When a law is passed, it's passed for the public. So all people should be sampled randomly across age groups and socioeconomic backgrounds. All right. Okay. A survey is conducted to determine the average number of hours college students spend on social media per week. The sample is taken by selecting students from one prestigious university in an urban area. What is the potential issue with this sample in terms of representativeness? So it's selected from a particular university in an urban area, and my question is average number of hours college students spend. So this is actually biased towards students from urban areas and prestigious universities. Had my research question been that I want to determine number of hours college students in urban areas and prestigious universities spend, then it would have been representative. But my research question is for the general public. So if I sample from one university in one particular area, then my sample would be biased towards the students from that area. Okay. What is a sampling frame? So a sampling frame is actually the list of all possible individuals or units that could be surveyed. And 20, what is the key difference between sampling frame and a population? So a sampling frame is a list of the entire population, while population is only a subset of the frame. No. A population includes all elements being studied, while sampling frame is a subset of the population used for sampling. So it is actually a list of all units that could be sampled. Okay, so this is one major difference between sampling frame and a population. So I have a few more questions, but I'll end today's session. Maybe we'll refresh these concepts in the next week before we take up week 3 doubt clearing sessions. So thank you so much for joining, and I'll see you in the next class.